Right, in this recording I'm going to talk a bit about quantum physics. Now, where should we start? Okay, let's start with the wave equation and Young's slits. Well, if we have a wave equation, it seems to travel between the slits and the screen, and then when the whatever it is gets to the screen, we get this interference pattern. But one of the strange things about the wave equation is that something seems to be travelling through space, but it's not a particle and it's not a wave. It's kind of a wave equation. But the only way that we can tell that this is happening is if we actually realise and decohere that wave equation to give an interference pattern or an indicator on some counter. Then we know that, for example, a photon has arrived at a certain location in space. But until it does arrive, that particle or photon, whatever it is, leaves no track of how it got from its start to its end point. There's no possible way of proving which way it went. And since it leaves no track at all, this is proved time and time again, one has to ask, is anything physical travelling at all? And the logical answer would be, well, no, it's like a mathematical equation is travelling, the wave equation, but nothing physical that we can detect unless we detect its final point. But I'm talking about the track from its beginning to its end. There's nothing detectable. There's no way it leaves any evidence of which way it went. So one has to ask the question that did anything physical travel at all? Now, in a digital theory of the cosmos, that's quite easy to explain because it's actually an algorithm that's calculating the position of the photon, and it doesn't actually implement itself or realize itself until this algorithm agrees that it's reached its destination, and then it decoheres and exhibits itself, and that would only consist of giving a value at a certain location in the Heisenberg area. But on its journey from one place to another, it's not there at all because it's an algorithm that's doing it, and consequently that's why we can't track it or see which way it's been. Another supporting point about this is in a lot of quantum physics this phenomenon occurs. For example, quantum computing. You set up an algorithm that the wave equation can go down 100 paths, but only when it's calculated the result do you know which path it went down. Well, this is an obvious candidate for an algorithm. I mean, how can anything physical go down 100 different paths, for example 100 optical fibers? They have to be there, but it seems like it only went down one, the one that gave the correct answer in the quantum computing. So what about the other 99? They have to be there, but there's no evidence that anything went down them at all, unless you think a wave equation is something. But a wave equation is not a physical thing. It's a calculation. It's an equation. You can have a look at it. So again, the obvious answer to that, a very easy answer, that it's an algorithm that's calculating the final answer, and that in each of the other 99, the algorithm is there, but it won't realize any output of value unless it arrives at its correct answer. So that's another supporting evidence, if you like, for the digital nature of the cosmos. People have a great difficulty explaining that. In fact, they can't really explain it. They say it's some weird, bizarre quantum effect that a wave equation goes down 100 fiber optic pipes, but only exhibits in one of them when the answer to the quantum computing algorithm is given. But if you consider that it's actually an algorithm, and it's not traveling, it's an algorithm in a data reference frame that's traveling, if you like, or you can even say it's not in space, it must be in time, but it's not actually in space, it's just behind it, and it outputs the answer when it finds it. So I'm sure a lot of you will agree with this as a good conceptual, it's even an easy explanation of what is actually going on behind this so-called quantum bizarreness. In a digital world where things are algorithmically calculated, it's not so bizarre at all. Right, thanks for listening. Don't forget to listen to the next video. Bye.